All right, so we're going to go through the simulation together for this Waves Lesson 4 Sim Lab. You should have already done your bell ringer and your attendance. We reviewed waves. We'll watch Mr. Anderson after we do the simulation. You have a choice today. You can pick the PDF or the Google Doc. I don't care. It's the same questions. But you'll find the sim embedded below. I'm going to go ahead and reset it. This is what you should see when you open it for the first time. And we're going to go back and forth between the instructions in the lesson. Okay, so let's zoom this in a little so we can see it better. All right. In the simulator, change the speed from normal to slow motion. All right, one thing at a time. Change the speed from normal to slow. So right here in the middle, we're going to go slow motion. And then move the wrench up and down and watch how the wave travels towards the clamp. Right? So notice we have all the crest action. Then when it comes back, it's all the trough. It's all on the underside. So let's look at it again. All right, next instruction. In a couple of sentences, describe what you see happening to the wave as it travels down towards the clamp. So you should take a little bit and describe that. You see all crests and then all troughs. Even if I go up and down and up and down, it's all on the top and then all on the bottom. Okay. So you should type something in there. Okay. So let's look at the next instruction. Now turn the dampening up to lots and move the wrench up and down. In a couple of sentences, describe what you see happening to the wave as it travels down. All right, so dampening is right here. It's at almost none. We're gonna put it all the way to lots and see what happens. Okay, watch again. If I really go crazy with it, the wave doesn't even hardly make it to the clamp. So let's review. At no dampening, the wave makes it all the way to the clamp and all the way back and continues. Okay. But with lots of dampening, the wave doesn't get very far. All right, so you should, in a couple of sentences, describe what you see, what is happening. And then tell me in your own words what dampening does to a wave. Make your own definition. So what does dampening mean? So right here, you're going to click in dampening means what? Well, let's go on to number 4. Hit the reset button in the simulation. All right, there's one instruction, reset. Change the setting on the left from manual to oscillate. All right, on the left, right here. Manual to oscillate. Set the amplitude to 1 and the frequency to 0.5 and observe the wave. Okay, amplitude to 1. And the frequency to 0.5. And observe the wave. Okay. No, it's the way it really is. Because look what happens. What they're trying to get to, if we look at the questions here, and then you're gonna change the frequency to 1 and write and the difference you observe. So you're gonna make some observations. So the frequency is 0.5, that's what we get. If we put the frequency to, what would it say, 1, about 1, this is what we get. What do you notice? We bring it up to 1.5. What is changing? how many waves there are in that space. That's absolutely what's changing. So if I go crazy and make the frequency as high as I can, which is, 3, as we watch this, and also we probably should make dampening in the middle so we can really see it. So we'll kind of review that. If we go down to a very low frequency, it's almost too much to handle. If we make the frequency come up, just notice what changes as the frequency goes up. Just like Matthew said, it's more waves in this space. You notice you can see more crests, more troughs. Okay, so in that question, and write the difference that you observe. Higher frequency gives you more waves in this space. All right. Let's look at our next instruction. Now set the amplitude to 0.5 and write the difference you observe. All right, so we had frequency. Let's take it down to somewhere in the middle. And we're going to change the amplitude. So we can kind of talk about this a little bit. If we go to really low amplitude, let's reset it. Really low amplitude. Okay. Now what's going to change as I go to a higher amplitude? The wave, the height. You said the height, and what'd you say? Okay. If we look, this change right here in the oscillator is greater. So we can see the crest goes higher above, the trough goes lower below the midline. Let's make amplitude as high as we can make it. And so we get the tallest wave that we can get. Yes, you can break it. Yep. We can. Yeah, we're going to break it here in a second. It'll be fun. But and so you can, like he was saying, if we put dampening all the way up, the wave can't get to the clamp. But if we put dampening all the way down, then, and frequency all the way up, we kind of get, it goes out of control. Okay, yeah, so we'll put dampening to normal. Oh yeah, you're right. So when we put it on normal, notice, and we want dampening on none. And so why is that? Let's talk about why does it get broken. That's making me dizzy. Hold on. Pause. All right, so why is that? Because the wave is starting here, but what happens when it gets down to the clamp? It comes back, right? Like it doesn't necessarily stop, but the wave comes back and you get interference in there. And so that changes a lot of things. So we'll go back to slow motion so that I can actually make it through the lesson. Let's see. Tell me in your own words the definition of amplitude and frequency are in waves. So again, amplitude, let's kind of make this a little more normal here. When we play this, when we change the amplitude, what do you notice is different? The height of the wave is different. Okay? But when we leave amplitude alone and we change frequency, what is different? This it kind of like speed, but it's the number of waves in that space. Okay? And if we look at the oscillator, my frequency goes up, goes a little faster. Frequency goes down, the oscillator goes slower. So it is to do with the amount of times the wave is created in that space. Some people will argue about frequency being like speed, but frequency is per second. So it's not a distance per time, but it is an occurrence per time. So, all right, let's look at our next instruction. Or you should have a definition typed out there. let's look at number 7. In terms of energy, does this setting show us a wave with a lot of energy or a little bit of energy? Well, let's look at the setting it told us to be on. Amplitude at 0.5 and frequency was at 1. So if we put that back to that setting, about 1 and amplitude about 0.5, what do we know about energy? Well, let's bring amplitude up so we can see the wave a little better. Which one do you think has more energy? This wave or this wave? That wave. So what did we change there? The frequency. When my frequency is low, if I have a low frequency, that looks like a lazy wave. Okay, there's low energy there. It's not getting the energy, even you can see from the oscillator, not much going into it. But a high frequency, that oscillator starts moving, there's more energy being put into the beads, to the wave. So you guys are smart people. You look at it and you can tell, okay, all these science words, but that wave right there has more energy. So let's put in the vocab. A high frequency wave, this one, has more energy than a low frequency wave. We can see more motion. We can just see more action. Okay? So that's a big part. Take away the words for a second, look at the observation, and then add the words back to it. So the high frequency wave has more energy than the low frequency wave. And so we're looking at 7 and 8, really, in terms of energy, does this setting. So that setting was a very low energy setting. How does a high frequency and low frequency wave differ? What we just talked about. High frequency has more energy. Low frequency has a lower energy. Okay?
My age shows boxes and you get a draw.
Oh, that is what I changed on it. So just type it. Just go through there and type, because you can't draw on that. Thanks for pointing that out. I forgot that part. So, yeah, just tell me how it's different. So, low frequency, high frequency. All right. Let's go ahead and look at number 9. It says now turn the amplitude to 1, and on the right hand of the screen, change the option from fixed end to loose end. Okay, too many instructions. Let's go with just 1. Now turn the amplitude to 1. Okay, amplitude, we want it to be at 1. All right. On the right hand of the screen, change the option from fixed to loose. Over here, fixed to loose. Okay. In the lower right hand area, check the box that says reference line and drag it so it lines up with the top of the green marble. Okay. Reference line, and we want it to be at the top. So we're going to pause it. All right, and then what are we supposed to do? You'll notice that the green marble never goes above that line. Turn dampening to none and watch what happens to the ring on the pole. Describe what you see below. All right, dampening to none. Notice this loose end. How is it different? Yeah. Notice what happens. So he said his is breaking again, but same concept.
It's like the ring that's on the rod that shows. Yeah, it's just.
Yeah. Why? Why is that happening? That's what we're looking at. Think about the energy that we just talked about. Energy from this oscillator is still going in to this string of beads. Okay? But because this loose end isn't fixed, it's loose, it can change, it can go higher. So it's kind of like a swing. Have you ever been on the swings and when you were little tried to go all the way around? Because you thought you were going so high. Your little legs weren't kicking any harder. You were still putting in that same energy, but it was taking you higher. Same concept with the ring. Okay. Okay, so the same thing, we're putting energy in, and it has to go somewhere. That energy can't be lost, and it can't be, so it has to go somewhere, and that goes into the wave. Since it's loose, but not. Let's look at what no end does. So no end, there is no interference. There's nothing coming back to it. Why doesn't it lose its mind? Why doesn't it go crazy? It's continuous. It just keeps doing the same thing. Whereas the loose end, that energy is coming back. It's just coming back more and more, like amplified. And that's that amplitude gets amplified. It gets bigger and bigger. Okay. So let's go back to our questions and make sure we answer all those. And why do you think that's happening? We just kind of discussed that a little bit about the energy and how it's still going into the weight, into the beads, and how at that end it still has to come back. The energy still comes back and it amplifies the wave. Okay, so type something like that. And then you're going to submit this paper to today's lesson. And then we'll go on with the lesson.